here is a wave which is traveling in right direction, that is positive direction of x. Okay, so first we get here and then the crest keeps on moving in this way. Now this wave can be imagined in two types of variables. If we make a graph of a wave, there are two types of variables. The wave is moving in this direction. So one variable is this displacement x. X keep on changing. The other variable is time. The time keeps on changing. And with x and t, what are the other things which are changing? That is the displacement of the particle. When x is here, the displacement is so much. When x is here, the displacement is this much. When x is so much, the displacement is here, and the x is so much, displacement is here. So we find with the x, what is the other thing changing? This displacement, and this displacement we call as y. So what are the variables in a wave? The displacement of particle y, we will also call it the displacement of the wave. The displacement of the wave, the distance travelled by the wave, the time taken by the wave, these at one point. These are the variables. Okay. What are the constants in this wave which throughout the propagation of wave are not changing? That is, wavelength lambda is not changing, time period is not changing. Time period is time taken for one wave, and that is t. The distance between two peak value lambda is not changing. So these are the, and velocity. Velocity is wavelength multiplied by frequency. So the frequency is not changing, wavelength is not changing, time period is not changing, omega is not changing. So these are the constants. Can we name it? Yes, let's write it. Variables. I will write it here. Variables y, x, t. These are variables. Constants. Omega, angular velocity, lambda, frequency, number of cycles, total time period, this, and amplitude A. Initial phase, which comes only once, that is phi. These are the constants. Again, you know the name, I am not writing it. Frequency, wavelength, linear frequency, time period, amplitude, and initial phase. Displacement at time t at distance x. At distance x, how much is the displacement? Y, and how much time has passed? Small t. So these are variable. When the wave reaches here, the time value change, x value change, and the y value also change. So these are variables. Now, what is meant by an equation? Equation means if we establish a relation between y, x and t using the constants, then that relation will be known as equation of the wave. Okay, so we will try to find out different equations of the wave. How wave travel one wavelength? How much time it takes? So it takes the time when this particle makes one full oscillation. So time period of oscillation is equal to time period of the wave, because when oscillation is made, there is one peak on this side, one peak on this side, and again displacement is 0. Displacement is 0, one peak on one side, one peak on other side, again displacement is 0. So during this oscillation period t, the disturbance has come from this point to this point. That is why the time period t is the time period of oscillation as well as the time period of the wave travel. How much travel? lambda. So in time t, how much travel is done? Lambda. How much is the phase change? 2 pi. This phase we have taken from here. This turns 2 pi and from 0 it goes to peak value a, then come to 0 minus a 0. 0 plus a 0 minus a 0. How much is the phase? 2 pi. How much is the travel of the wave? Lambda. So in lambda the phase change is 2 pi. In time period t the phase change is 2 pi. Okay, and here we see this omega t, this convert into pi by 2, 1 pi, 1.5 pi and 2 pi. This is how this theta keeps on changing. Now we have to relate them. Okay. When we relate them, there are two types of relations. One, y related with x. Another, y related with time. How can we do that? Just imagine if y is to be seen as changing with x, then t is constant. T is constant. How can we make t constant? Okay, the answer is by taking a photograph. When you click your mobile in a fraction of a second, that everything freeze in the picture. How much is change in the time? 0. Then, okay, a wave is coming, a water wave through the stone in the water, and a wave travels like this. And you find the water goes like this. At any instant, take a photograph from the side. At that time, you see in that is a still photograph. So time freeze, time is 0. And what you find, some particles are up, some particles are down, some particles are up, some particles are down. Here, what is 0? T. The time is not changing. So what you find, at which x, what is the value of displacement of the particle? If x is this is the displacement of the particle. If x is this is displacement of the particle. So that is when the time is 0, and if I make an equation for that, that will be within y and x. Okay, that is relation between y and x only, because t has been eliminated. Now other thing, I stand here and do not change my position of the camera, and now my camera is a movie camera, video camera, and I pose it here. I do not change its position. Since I am not changing its position, I say I have frozen x. X is what? Displacement. I am taking photograph only at this place, not taking photo here, not taking photo here, only at this place. And again the wave comes from here. Here I find sometimes the water level is this much. Then it goes like this, then it goes like this, then it goes like this, and I make a table. In that table, what do I write? T is equal to 0, y is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3, and y is equal to 5. T is equal to 4, y had decreased to 2. T is equal to 5, y had decreased to 1. T is equal to 6, y is again 0. T is equal to 7, 8, 9, y is equal to minus 3. So what I am tabulating? Time versus y. What is happening here? What's happening here? I don't see. And I make a graph. That graph, time I take on x-axis and y I take on y-axis, displacement. How will be the graph looking? Same graph. This is time, and at this time displacement is 0. At this time displacement has maximum, At this time again 0. At this time displacement is less because the wave is coming like this. I am seeing here. I see water going here, water coming here, and the time is passing. 1 second, 2 second, 3 second, 4 second, 5 second, 0, again 10 second, again 15, again 20, here 5, 10, 15, 20, 25, 30. The time is increasing and this height shows me the level of the water. This is the graph between what? This is the graph between y and time. So I can have two type of graphs. One, displacement versus time when x is frozen. Other one is displacement versus x, time is frozen. Okay, now what are the relations? Here we see the oscillations. In this oscillation, if we take time variation and oscillation, here the time is changing, here the time was 0 and at this point this time is t. At time t, moving with angular velocity omega, this theta is equal to omega multiplied by t. Now in this graph, this is the displacement y, and if this is the displacement y and we take wave, how much wave has moved in forward direction at that time, this is the displacement x. But right now we are considering only y and time. So we have a relation y upon a is equal to sine omega t. Y upon a is equal to sine omega t, that is sine theta. So y is equal to a sine theta, that is y is equal to a sine omega t. This is relation between y and t. Got it? Here, have we considered anything about x? No. Let it change, whatever it is happening. We will consider only y and t. The time is passing, the y is changing. The time is passing, y is changing. This is the equation, y is equal to a sine omega t. Now, take the second thing, x. How can we relate x? We know this equation, y is equal to a sine omega t, which has come from the trigonometry of this. Now, I tell you one thing. When there is a distance covered lambda, how much time pass? T. Can we find out how much time will pass when the distance covered is x? Answer is yes. In x direction, lambda is the travel in time t. Then how much will be travel in 1 meter? T upon lambda. And how much will be travel in the time when the displacement is x? So y length is travelled in time t, therefore x length will be travelled in time t upon lambda divided by x. This is the time taken for travelling x, and time for travelling x, how much we have taken it? T. So the position will be x in time t. So this t has value how much? T upon lambda into x. Once again, lambda travel is done in time t, therefore x is the position in time t upon lambda multiplied by x in that much time, and that time when x keep on changing, time keep on changing. So this t upon lambda into x is equal to t. Now you place this t here. So what do we get? Y is equal to a sine omega. What is omega? 2 pi upon t into small t. Small t, we put this value here, t upon lambda into x. It is cancelled and we get this equation. This 2 pi is a constant and lambda is also constant for wave. So this whole constant, we name it propagation constant and write it k. So what is our equation? Y is equal to a sine kx, where k is a constant. Now here time does not appear. This is a relation y and x. So we have separate relations for t and relation for x. T and x. What is relation for t? y is equal to a sine omega t. What is the relation for x? Y is equal to a sine kx. So I will write these two equations separately and clearly. And now the important thing, we want to combine both, because here x and t both are variable and both are changing. So we find a relation how x and omega t, do they change together? The answer is no, they don't change together. And there is a very important thing. See, if this is moving in this direction, positive direction, so omega t value is increasing, y is increasing. What is happening to x? Yes, it goes up, x decrease. But we want to increase x. If we want to increase positive direction of x, what will happen to omega t? The answer is, if we move omega t in negative direction from here to here, what will happen? X will this. If omega t is negative, x will increase. So when x is increasing in positive direction, what is happening to omega t? The phase is decreasing. So when x is positive, the phase is negative. Okay, so if there is a movement, like this, how much is the movement? The answer is, this angle, remaining angle is omega t, so there is a decrease. How much? This much. How much is this? This total angle was how much? This is. Remaining is this. Then how much is this movement? That is, this movement means this propagation. How much is this propagation? I will say this is theta 1 minus theta 2. Theta 1 is how much? This. Theta 2 is how much? This. So, how much is the movement? Theta 1 minus theta 2. So, my equation is y is equal to a sine, here theta 1 minus theta 2. Theta 1 I place as 2 pi upon lambda. This I will call k, and this I will call omega. So, this is kx minus omega t. Now I have an equation where y is related to both x and t, and this relation speaks about not the stable or at one location wave, one location motion. This speaks us about the change. Change in what? Change in x from this point to this point, that is this change. And this is what? Motion of the x, motion of the wave. So, motion of the wave is given by this equation. So, this is location of the point, but if the wave is traveling, in which direction? Positive direction of x, then this is the equation. And why we have done this minus, you have seen that. Now, we remember one thing. If this is the format, then this sign is negative. Why? Because we have to do the minus, this total minus this thing. Then only we get how much x has increased in this direction. That means if the wave is traveling in positive direction, we will get a minus here. And if the wave is traveling in this direction, then this has to move this way, omega t will go on adding up. And this gives a very wonderful thing to us. We see here and we can always predict what is the direction of motion of the wave. If it is minus, then the wave is traveling in positive x direction, and if this is plus, the wave is traveling in negative x direction. And this is equation of the traveling wave. So now we got equation of the traveling wave. Equation of traveling wave is y at any instant at distance x time t is equal to amplitude A into sine, and angle of this sine is kx minus omega t. This is equation of traveling wave, and this is traveling in positive direction of x. Here again 2 pi upon lambda we have converted into k, and we make it an important quantity. We will call it propagation constant. How can we define it? This is the change of phase per unit displacement. That means if there is a displacement of y, how much phase changes? 2 pi. With y displacement, phase changes are 2 pi. Therefore, with unit displacement, how much is the phase change? 2 pi upon lambda. Unit means the wave moves 1 meter. There is a change phase. Depends whether wave is this way or wave is this way. So, whatever is the phase change by traveling 1 meter, we will call it propagation constant, and it is given here. So, remember 2 pi upon lambda is what? Change of phase per unit length, per unit meter, per meter phase change. We call it k. And when the wave is traveling every 1 meter, so much phase will be changing. How much phase will be changing? 2 pi upon lambda. That's why its name is propagation constant. This thing remains constant when the wave is propagating, and we call it k. Okay, remember this. Then another thing, angular velocity omega. This is again phase change, but this is not per unit length. This is per unit time, because both things are changing. So 2 pi phase change in how much time? 2 pi phase change in time t. Write it the other way. In time t second, the phase changes is 2 pi. Therefore, in 1 second time, how much will be the phase change? 2 pi upon t. So, every second the phase is changing, and we call it omega, rate of change of phase. That is angular velocity. So, this is angular velocity of the wave. 2 pi upon t, and this is also a constant, because every one wave it takes equal time. So, this is another constant known as angular velocity. We know 1 upon t is equal to frequency. So, this can be 2 pi into frequency. Now, frequency in one cycle, the angle change is 2 pi. So, if we are multiplying frequency with angle, its name will be angular frequency. So, this quantity is angular frequency, and this is equal to angular velocity. Both are one and the same value. Okay. So, that we are going to use in this relation, So, this is our equation where k is equal to propagation constant, omega is equal to angular velocity. With this equation, what is the information we get? We get an information that amplitude of this wave is so much. Lambda we will get from here, because this is 2 pi upon lambda. This value gives us frequency, because this is 2 pi nu, and this gives us time also. Then it gives us velocity also. How does it give it velocity? The velocity of the wave, we know it is equal to lambda into frequency. So, here we get it omega upon k. Omega whatever is multiplied with t is omega. Whatever is multiplied with x is k. So when these two quantity we divide, what do we get? Velocity. How? What is omega? 2 pi nu. And what is k? K is 2 pi upon, no, k is 2 pi upon lambda. So divided by 2 pi upon lambda. So here this is cancelled, this goes up and it becomes nu into lambda. And we know nu into lambda is velocity. In 1 cycle, the length covered is lambda. In 1 second, nu cycles are there. Therefore, in 1 second, how much length is covered? Lambda into nu, and that is equal to omega upon k. What is the use of it? Whenever you see an equation, like if you see a wave equation which tells you that y is equal to 10 sine 5x here minus 20 t. This is equation of a wave. If this is equation of a wave, then I ask you, what is the amplitude of the wave? Amplitude. Amplitude is written here. I write one model equation here, a sine kx minus omega t. This is standard format. Now compare. How much is amplitude of the given wave? 10 centimeter. What is if it is in centimeter? Okay. Then what is lambda? This multiplication of x is always equal to k. So 2 pi upon lambda is equal to 5. So how much is lambda equal to? Lambda is equal to 2 into 3.14 multiplied by 5 meter. This is lambda. Okay. Then how much is frequency? So 2 pi into nu is equal to 20. So nu is equal to 20 upon 2 pi, that is 10 upon pi. This I got frequency here. What is velocity of this? Velocity is simply omega divided by k. Omega divided by k. 20 upon 5 equal to 4. 4 is the velocity, 4 meter per second. So by seeing an equation, you can find amplitude, lambda, frequency, velocity, all these features. Yes, one feature is left, that in our equation, this initial phase, we always started from 0. Suppose here is our time is equal to 0 and the particle start oscillating from here. Then this is the initial phase, we call it phi. This is the initial phase. It may be here, it may be here. If it starts from here, t is equal to 0, then this is phi, and you will see it start from this much displacement. It start from this much displacement and not from 0. This is known as starting phase, initial phase, and that is written in the equation at omega t minus phi. This we are going to make a deduction first, and after that we will do the calculation. So that appears at this point. So I will extend it. Please extend it. This is phi. Or you can simply write minus phi. So here, if there is something written, that is initial phase. So if it is given to us plus pi by 6, then what is the initial phase? This one. Kx minus omega t plus pi by 6. This is initial phase. And then if it is asked to us whether this wave is traveling in forward direction or reverse direction, we will see here omega t, it is negative, and this shows it is traveling in forward direction. So this is equation of the wave, and how we recognize it you can also make equation of wave. If all these values are given to you, you can write an equation like this. So in an equation, y, x and t will be written as it is, and all the constants values will be given. So this is all about equation of the traveling wave, kx minus omega t. If it is only kx, if it is only omega t, it is oscillation. If it is kx minus omega t, it is motion. Thank you.